progressing. Yeah, let's know.
Yes, I'm currently on Git.
Okay. That means you're far ahead of us. That's fine.
Yes.
I actually love that. And you've completed your certification, so definitely far ahead of the class. Congratulations. Thank you. I love that. Well done. Keep it up. But so far, have you faced any issue, any challenge in any of the talks?
No, I've not faced any challenge so far.
Okay. That's the beauty of that camp. I don't know how they do it. They just simplify all of these concepts, and even as a beginner, I get to understand these things you think was like worlds apart before. I love the way they simplify their courses anyway, and the short videos that they always do. Can we hear from you now? Or you're still not available?
Hello, good evening. Please, okay, you can hear me. So, currently, I'm already on my Python courses. Then because of my busy schedule, I've not been able to write my certification exam. But fortunately for me, this week I was free a bit, so I did a part of the certification. So hopefully today I'm going to complete the practical aspect. So, but I'm on my Python courses already, and I'm following up.
Okay, that's fine. That's great progress. So your Python courses, are you in line with what we're doing right now? Are you in line with the current assignments, or haven't gotten there yet?
Actually, because of I sacrificed the time for this week assignment for the preparation for my exam, for the certification exam. So the only gap now is this week assignment. So, and by tomorrow I'll be able to go through it and work it out. So that's
Okay.
just it.
Oh, that's fine. Hold on. That's great progress, and I love that. So the Abasiofon, good evening.
Good evening, ma.
Good evening, and welcome to this session.
Thank you.
How have you been, and how are you progressing?
Fine, thank you. I've been following up on the assignment.
You've been following up, or you've passed us?
I've been following up.
Okay, well done. And you already have a certificate, right? Yes, the associate. That's where we're at the moment.
Yeah, I noticed. I think you removed the professional one because it was showing late for me.
Explains that there was an assignment for the associate, so I just used that at least as a reminder that at that stage we need to register and write an examination. So as soon as that expires, I move that. So that shouldn't be a problem. Whether late or it shouldn't be a problem. Well, well done. Maybe Shakira. Hello, Shakira. Welcome. Good evening. Can you hear us? Okay, she sent a message. All right, welcome to today's session. So this is 6:11, and I guess we just have to start up. Good evening, everybody, once again, and welcome to today's session. Like I said, we couldn't hold it last week because I was unavoidably absent. I couldn't make up. So today we're just going to see how far we can go in the one that we missed last week. So in our previous session, I think the last one we did, we talked about understanding cloud computing, and we looked at Python libraries. And we looked at various Python libraries that are useful for data engineering. So those are some of the things that we looked at in our last session. And we've also talked about the basics of Python. So today we are going to look at lists. We'll look into lists. We'll look at dictionaries. Look at Python dictionaries. We'll look at list comprehension. Then reading files in Python. And then we'll also look at how to basic error handling in Python. So we're going to start now, and let's see. I'm going to see if I can share my screen. Okay. No, not ready yet. So let's start. Starting first of all with lists. What do we say lists? Lists are like a special kind of. Let me see if I can share my screen immediately so I don't get there. Sorry, let me share this. So please, for patience. Let's see. Okay. I hope this. You all can see my screen, right? Can you see my screen? Let me know if I'm talking to myself again. No. Okay, thank you. Please, if you can, could you respond so I'll know I'm not talking to myself or I've not been taken by the network. So today we'll be looking at lists, dictionaries, list comprehension, data frames, reading as in Python, pandas generally. So starting first of all with lists, we say a list is a special type of say data type in Python that hold more than one item at the same time. Now a list is very useful because now a list is useful in Python because it can hold more than one item and you can easily call the item whenever it is needed. List can be called using either the list collection or simply by putting two square braces in in a variable. Declaring the variable using two square braces or using the list collection. And first of all, we'll start by declaring a list using two braces. So we'll call our list underscore n to be equal to two square braces. Now this, as it is like this, list underscore n is now a new list. Then let's run this and I'll see something. Then the second method of doing that is using the list collection, where we say list NB equals list. Now, this second method also is a way of declaring a variable as a list. Now, the difference is this. Though they do the same thing, but the difference is in their speed of execution. As a data engineer, one thing we should always have at the back of our mind is the best at the most efficient way to get data from one place to the other. And even during that process, the best and the most efficient way to get what we want. So running this two now, if you look at the runtime, for the first cell, the runtime here is 0.2 seconds. And for the second one, the runtime is, this one is usually, hold on please. Zero point 0.0. Okay. The first method is actually the faster of the two. That's why it's always encouraged to use this first method in creating a list. So as it is now, this is an X list that we have given to the variable called list_n. So I'll just delete this because we would use only the first one. So we can put as many items we want on our lists, and let's just fill it with numbers. And what's this? 8. Okay. Yeah, this is enough. So if we have a list containing these items, to get first of all, we need to know the length of our list, because most times a list might contain up to 1,000 elements. An item in a list is called an element. So a list contains all 1,000 elements. To get the number of elements in a list, we use the len function, which is short for length. So if we get this and use the len function, len list underscore n, okay, so our output here is 6, telling us that our list contains 6 elements. Now, what this means is that our list contains 6 elements. However, if we want to get an item on the list, we do not use the length. We use what is called the index location. And index location goes from 0 to the length of the list minus 1. So having that we have a list with 6 elements here right now, the index location of this list will go from 0 to 6 minus 1, which is 5. So the index locations of all the items on this list will go from 0 to 5. 0 having been the first element and 5 being the index number of the last element on the list. We can actually get that. We can see that by running by running the index location, by checking with the index location. So to check that, we just use this name and then we add the index location. So if we want to get the value of, say, the number in the second index location, that's 2. Okay, we get the value of 7. And looking at this, so we see that 7 is actually the index location is 2, though it's the total element, the index location is.
You are breaking. I don't know if it's
to
only
get
me that
one for the last element. We have since it's 0 to 5, we can use 5. Sorry about that break. I lost my connection a bit there. So I hope you all can hear me.
Yes, we can, but your line is breaking.
Hold on, let me see if I can adjust this. Can you hear me now? Sir? I hope it is.
It's better now.
Okay, thank you. So let me share this my screen again and let's continue. Okay, so what I was saying that was we could also check the last item on the list using the index location of 5, since we have that since we have the length of our list as 6. So the last index location will be definitely the limit of the list minus 1, which is 5. And when we run this, we're going to get 8. Yes. So another ways of getting this is using minus 1. When you use minus 1, we're starting from the last element of the list down to the first element of the list. So to get the last element, we can also use minus 1, and it will give us the same item, the same element, which is 8. So then we'll look at how to access a range or more than one item on the list. Now, if, for example, we are looking at assessing, we want to see the items from the index location 3 down to the last element. 3, first of all, since we're starting from the index location 3, then down to the end, we add this is a semicolon, and that's it. And we end blank like that. And when we run, we're going to get a list from the 3rd index location down to the end. So these are various of assessing. This is how to assess items on a list. The type of comprehensions. What is a list comprehension? A list comprehension is simply an easier and a more straightforward way of writing a for loop. That's the best way I just like explaining. Is a writing like a for loop in one single line. Now, how does this benefit us? Just like I said initially, when we're writing codes, we try to find the most efficient and the fastest way to get to where we're going to. A for loop is good. It is very, very functional. Yes, it can get us to where we're going to, but a faster way of getting to getting a result, a faster way of getting a result rather than using a plain for loop is to use a list comprehension. And using a list comprehension, you just use one line to write everything in the for loop, and you have the result you're looking for. So we're still going to use this list underscore n as an example. Now we'll just write a bit of code to say we want to get the odd numbers in that list. So for us to do that, first we're going to use the for loop to get it. Then secondly, we'll write it in form of a list comprehension. Then we'll check the time both methods used to run, and we'll see the one that is faster, more efficient, and easier to understand. So to do that, we say for num, let's use num as a variable name. For num in lists underscore n. Okay. So we want to check for an odd number, and to get an odd number is simply any number I divide by 2 that is not 0. If the result is not 0, it is an odd number. And if the remainder is 0, it is an even number. So we're going to say if num then remainder division 2 is, where is the not? Not equal to 0. Then what do we do? Let's say just num. Okay, so this has given us the results of numbers in that list. But to put it in a better way, we can simply, first of all, have declare a variable as an empty list. Then any number that is an odd number, we just add it into that list and print the list after the for loop runs. So we can call it odd. Odd is an empty list. So rather than printing the number, we are going to say odd dot append. Append is a method used to add append is used to add items or elements into a list. So we are going to append num into the odd list. Then at the end, we will print. We'll print odd. Run it again. Let's see what it gives us. Okay, so now we have a better output. So this has given us the odd numbers in a list. We can write this now using a list comprehension. Now to do that, okay, to do that, we're going to first of all say, okay, let's make this odd underscore n, that's odd underscore numbers. Then we're going to create a list, and in this list, we're going to write out the formula it will use to calculate and to give us the odd numbers that would be in our odd underscore n variable. So here we are going to say num, which is the variable itself. Then we'll use the for loop here for num in lists n. What do we want to do? we're going to pass the condition that would make that added into our odd number list. So we'll say if num modulus 2 is not equal to 0, and that's it. Then at the end we're putting n. So we run this, and okay, so we have the same output. Then let's see how long it took each of them to run. This one ran for 0.0 seconds. This has to be my network one. Let's see again. Zero one 0.0. Okay, so looking at the time both of them used to run, we can see that this one using the list comprehension is faster. When you get the beauty of this is when you're working with a large data set. That's when the timing will be very visible. It's when you see the time and you'll understand how a list comprehension is a better way of writing certain for loops whenever we're writing code to make our codes to be more efficient and easily understandable. Then we'll look at dictionaries. A dictionary, like we said initially in one of our classes, a dictionary is a key value pair. Unlike dictionaries. So unlike a list that the index location is used to access an item on the list, for a dictionary, we use the key to access the value. So a dictionary must have a key, because without that key, you cannot access the items on a dictionary. Additionally, when writing your keys, the keys should always be in quotation mark. The values can be either in quotation mark or not, but the keys must be written in quotation mark. Example of a dictionary can be this. Let's say this_n. Of course, a dictionary will start with coil braces. So this n is, let's see what we have. Okay, let's say name. For name, let's say Ayo. Okay. What else? Location, we can say in quotes. For location, we can say Lagos. Then so can we write? Okay, height. We can say 6.1. Of course, height and quotes. So this is like an example of dictionary, and this is a dictionary that contains 3 items. Being a key value pair, the keys here are name, location, and height. So if you want to access anything, any value in this dictionary, we're going to access it using the key. And unlike lists where you access it using the index location, here for us to access, like say IO, we're going to use the key, which is name. So that can be done like this. We run the dictionary. Then let's see how to access it using the keys. So to do that, dictionary n, which is the value of our dictionary, would be equal to, not equal to. So we use square braces and square brackets, and then we put the key, which is name. That gives us the value in name key. If we want to get say height, we simply put height in place of name, and we return the height that is the value in height variable. Sorry, in height key. Now, additionally, one of the something else we can get with dictionaries is we can get the keys, and we can also get all the values of a dictionary. To get the key of a dictionary, we still use the dot keys function. So for the example we are using, we can get the keys using dot keys. Okay, let's see. Oh, okay. So this gives us the list of the keys in our dictionary. We have name, location, and height. To check the values, of course, we just use also the values keyword, and when we run it, we get only the values, which is Ayo, Lagos, and 6.1. So it's different ways we can access the keys values of a dictionary, and we can also add values into a dictionary. To add the value, you simply write the key of the new value you want to add, then assign the value you want to add to that key. What do I mean? Still using the example, the dictionary that we have written above, we're going to add one item, and let's see, let's add age. Age would be equal to, say, 25. And when we do this, we are assigning age. We're adding age equal to 25 to the dictionary. We can also add multiple items to a dictionary using the update method. And to do that, we just call on the update method, and we assign the multiple values we want to assign. The key value pairs we want to assign, we want to add to a dictionary. We put it in the update method, and it is also added in our dictionary. So we have, this is update. So we're updating with okay, what else can we add here? Say course, COURC. Let's call it Python. What else can we add? I don't want to add email. Okay, last name. So last name can be Gerald. So we can run this and view the dictionary at the same time to see if it was added. Okay, so we can see now age has been added, course has been added, last name have been added to dictionary. So this is ways of, this is how to add a single or multiple items, multiple pairs to a dictionary. Then next we'll just look at how to work with data frames. Now, a dictionary like this can actually be converted to a data frame. A dictionary does not necessarily have to be just one value. The value of a dictionary can actually be in form of a list. So we can use another example. Let's see. Okay. Let me copy this one and then we'll expand this. We'll expand this, then convert it to a data frame. Let it NA. Okay, so we have name, location, and height. I'm going to make this, each of these values, I'll put them, make them all a list that would contain at least 5 items. So we have IO, we have green, we have Rita, we have Moses, we have Foreign. We have Venus. Okay, so yes, we'll do the same for location. We have Lagos. We have Cape Town. We have Kigali. That's 3. We have Jos. And we have Accra. So for heights, we do the same for heights. .14, 5.8. So just put 5 different heights. 5.6, 5.6. Okay. So this is this is the dictionary, and we're going to convert this to a data frame. Now, first of all, before going there, for us to actually access the items in this dictionary, first of all, to access the item first, let's look at name, the name part of it. First, to access the name, we'll use the name like was, we'll use the name key like was done initially. Then to get the let's say Rita, we're now going to access this part of it like we access a list. So what that means, to say we want to return Rita, what we're going to do is, first of all, we're going to write the dictionary name. Then we'll get the key. The key is name. And then the index location. Ayo has index location 0, green has 1, and Rita has 2. So here we put 2 here. Okay, no, this has to be equal to 2. we haven't gotten here yet, but let's return just the name first of all. What's in the let's get okay, so to get what is in the name, did I run this? Okay, I'm using the wrong. Am I still connected? No, is anyone still hearing me?
Yeah.
Yeah, I can hear
Yes, we
you.
can hear you.
I can hear you, Ogochukwu.
Okay, I was wondering if it has broken again. Okay, so I used the wrong dictionary name. Let me run this and let's run this again. Okay, so now I've used the right name. And to get Rita, yes, it's 2 that we'll have to use 0, 1, 2. Okay, so that's it. So that's how you actually access dictionaries in this form. However, when the dictionary is in this form, it could actually, like the name key can have as much as 1,000 values. It can have as much as 1,000 values. And if the name key has 1,000 values, location has the same number of values, height has the same number of values. Viewing it like this it's not that easy to understand, because now you cannot tell like Rita now, you don't know where to say her location is, and you could say Rita's height. Then you have like over 1,000 values written under one key. So for us to easily read a dictionary that is like this, it is being converted to a data frame. And a data frame converts a dictionary like this to rows and columns, similar to what we see in an Excel worksheet. Now, to work with a data frame, we need to import it using Pandas. And that's the importance of Pandas library for anybody that's in the data. The Pandas library is very, very important, and it's very vast. It has so many capabilities, so many methods, functions that can help us easily work with our data. So for us to do this, for us to put this dictionary now in a more structured format so that we can easily work with it, we convert it to a data frame. And to get a data frame, first of all, we have to import the Pandas library. And to do that, it's simply the import keyword, import Pandas as PD. Let's run. Okay, so we've imported Pandas now into our environment. Then after that, we will this dict A, we're going to convert this to a data frame. And to help us do that, we're going to use the data frame method in Pandas. So we will say okay, df equals pd dot data frame. Now, what we want to convert to a data frame is this dictionary. So just write this name inside here, and then we can view our data frame. value error. Why is it giving me a value error? They're all of the same length. I don't know. 1, 2, 3. Well, that shouldn't be a problem. Data frame. There's nothing wrong with this. From what I can see, I don't know why we should be having this error, because from what I can see, it shouldn't give this error. This one's don't make any sense. Here. I don't know what's causing this, because from what I can see here, it looks correct to me. Value error. Where is the error?
So I think the height 5.6
Oh,
5,
thank you.
comma
That's
6,
true.
1, 2, 3, 4, 5.
Oh, it's my eyes. Thank you very much. So run that. Thank you for noticing that. Okay, so that has solved our issue. Thank you very much once again. So it is now a data frame, and looking at it, it is easier to understand this than to understand this. So here we have the name, location, and height. Then we also have the index numbers that we can use to access any record on this data frame. So we have the name, the location, and the height as the column names. So in our dictionaries, this appears as keys, but in our data frame, the keys are actually made to be the column names. So the way we assess it is the same way we assess the name key of a dictionary. This way you can access that of a data frame. So in a data frame, we can also assess the index location. Like say we want to access this record 3 in index location 3, that's record 4. We can use the index method. We can use the index method to assess that, and that is df dot index equal to 3. Now we can do this. So let me run it to see what it gives us, and we'll see the alternative of. Okay, so now if we say the index location equal to 3, because we want to get the value, the record in index location 3, it will actually return true and false. The only place it returns true is where the index location is true, and every other record returns a false. Now, for us to adequately capture the complete record as it is in the data frame, we put this inside our data frame. We put this condition inside the data frame, just like this. And this, we should have the record. So with this, we now have the record in index location 3. Where anyone you want to check for the index location, you just edit and check for we edit and get the item or the record in that index location. Then we can also use a conditional statement to check. For example, using the height column now, we want to check and see those who are say 6 and above, whose height is 6 and above. So what we write, how we do it is, first of all, we get the height column, height, then check for that. The condition is for those that are greater than or equal to 3. The records where we have heights greater than or equal to 6. Now, if we run this again, like the previous one gave us, we're going to get trues and false. We'll get true and false exactly. So for you to get the exact record you want, we just put this also in the data frame and run. That should give you. So this gives us exactly those who are from 6 above. So we have 0 and 2, which we also have here. So these are basically the ways that we interact with, that we can get values from a data frame. Now, when we import data or import files into our system, Pandas actually converts it to a data frame. So these operations are actually operations that we use to work on our data. So we'll look at how to import data in Python using the Pandas library. So we're going to look at importing Excel and CSV files. We're going to look at importing Excel and CSV files. Now, to import an Excel file, it's also in the Pandas library. We use the read underscore Excel function. That we can get reads a lot of the functions. Okay, so the list we have here is actually the various ways we can read different file formats in Excel. We have read XML, read table, read SAT, read SQL, and the rest of them. These are the ways we can read different file formats in Pandas. So to read an Excel, we use the read Excel function. To read the CSV, we use the read CSV function, and so on and so forth. So these various functions are how we read files into Python environment using Pandas. So to read an Excel file, we say read Excel. Then we give the file name, example outline.x. So this is just an example of an Excel file name. So to read this file now, we simply use the read Excel, then the Excel file name. Now, if we use this, it is going to import everything on this Excel sheet. However, we have options. Pandas gives us different options that we can use to streamline our data importation. Now, where this is important is that when you're dealing with bulky files, you can easily streamline your imports. For example, you have a file that has, say, 2 columns, and you only need like 4 columns to work with. Read Excel, read CSV, they all give up different options that you could use to streamline it, such that you're not importing the entire 12 columns in your 12 columns of that file. Rather, you can import just the 4 that you need. Also, if you want to work with, say, the first 50 rows of a file, using the various options available in Excel, can I even guess? Let's see. Yeah. So using the various functions options available in the read Excel function, you can streamline it such that you only 50 rows out of probably 500. You can do it such that you're returning or you're importing only a certain number of columns rather than returning everything. So we also use return either 1 or 2 sheets depending on what you want. So for us to return, like, say, 1 sheet, we use the sheet name option. That's sheet_name. Now, in this option, you give it the this option accepts either the index number of the sheet you want to return or the sheet name. So if the sheet name is say sales, you just write sales. And if the index number is 0, you simply put 0, which is the index number of the sheet. That's one option. We also have the usecols option, which is used to columns. Use columns. Yeah. Okay. Use columns option. This will now tell the number of columns that you want to the range of columns that you want to import into your environment. So like we have columns A to F. Looking at an Excel sheet now, you have a sheet that contains data in columns A to F, and you want to work with just columns A, B, and C. So how you write that is simply A to C. So this now will import only columns A, B, and C into your environment. We have other options. We have the names, we have the headers, and so many of that. So to quickly know how these things are used, you just need to read the documentation for Excel and the Pandas documentation as a whole, so as to understand how these options come in and help us to streamline the data importation and data extraction into our workflow. Then we also have to read a CSV file. To read a CSV file, we use the read CSV, read_CSV. So, for example, we have a file, the same outline. We can use outline.csv. So basically, like this, we have already, if we run this, we're going to import the file with file name outline.csv. Now, CSV by default has like the name like read CSV, reads only CSV files. There is another type of file called a TSV, that's a tab separated value file. It's similar to a CSV file. The only difference is the separator. For a CSV file, the comma is used to separate one record from the other. Then in a TSV file, it's a tab that is used to separate one record from the other. So read a file like a TSV file. Pandas does not have a read CSV function. So we can use the read CSV to actually read a CSV file. Now, what I'm going to do is simply to add a separator. Now, this read CSV function has other options, just like the read Excel has different functions, different options that we can use when importing data. For us to import like a TSV file using the read CSV, we use the separator function, and for the separator, we simply put the tab operator there. Now, this is the tab operator. The separator is known as the SEP option, and then /and T. Let's put this as a TSV file. So to read a TSV file here, we use a read CSV, given the file name .tsv, and then we add the separator /c, because by default the separator of a read CSV file is actually comma. That's why when you read a CSV file, you do not need to start including a separator option, because by default the separator is a comma. But if you're reading a TSV file, you need to put the separator option, because the separator is not a comma but a tab. So this function, read CSV function, also has other options that can help us streamline our ingestion. There are things like use columns. We also have tools that you would determine the number of columns that we want to import. But this time around, rather than writing it like in a range like this, it is actually written in a list form. So usecols are equal to. So here now we can list the columns that we want to import. Say we want to import the name, we want to import ID, we want to import say email, and the rest of them. So for a file that has a huge number of columns, and you do not need that much columns in your work, you can easily use the columns to state the column names that you want to be imported, and they will be imported. Also, we have the headers option, headers. Now, what this function does is it tells the CSV if your file has headers or not. Now, by default, the headers option is actually 0. And that's why when you read the file, the first line which has index 0, the first line which has index of 0 is read as the header file. So if your file doesn't have header, it simply states here that your headers is equal to none. So with that, it doesn't take the first record, because if it doesn't have a header, automatically, and you do not state that your file doesn't have a header, automatically the read CSV is going to take the first record, the first row of, make it as the header. So stating as headers equal none, just read CSV that you do not have a headers in this file that you're importing. Or if by chance you have your headers is not in the first row, it is in the second row. The second row has the index value of 1. You can simply state that the headers is in index value of 1, and automatically it is the record in index of 1 is made your headers. So there are so many other options, like the columns we've mentioned, that we have the data type that you can use to explicitly state the data type of each column before you come into before you ingest them. You're already stating the data type so as to avoid type mismatch when importing files like that into your Pandas environment. Then we also have the names. Yes, names is what is used to, if you want to change the name, your column names, you use the names option. And similar to use columns, you also set this in a list format. So if we import say three columns and we want to change the column names, we can use this option to change the column names. We could give the first ID, the second first name, first name, maybe the third, say email, and the rest of them. So these are various options that are available in the lead CSV that helps us to streamline our workflow, and they help us to make our ingestion faster, more efficient, and also helps us handle certain kinds of errors that we would likely if we decide to import all of the files that we are working with. So after this, we're going to also look at a example of a data frame. Working with one data here. So, okay, before we go into that, let's see how to handle errors before we look into working with a broader data frame or with one data available on this environment. So now we want to read the CSV file, which we know, of course, is not available in this environment. And when we run it, we are definitely bound to get not found. So we're getting this error, file not found. Now, when working with data, especially during ingestion, for example, we've stopped our ingestion, our pipeline for ingestion, and it has been running. We've set the time when it should run automatically, probably on a daily basis. It's been running for a while. Then all of a sudden, there comes the time where there is a change in the name of the file. And like here, we actually have coded the name of the file here into our into our data extraction function. Now, if we write outline.csv as the name of the file that will be ingested on a daily basis, then there comes a time where the name is no longer outline.csv, but it's now giving outline as .csv. Definitely, we will have to run into a file not found error because the name has changed from outline.csv to outliners.csv. Now, if we build something that does not help catch that kind of error, once it gets to this point, once it gets to a point where it gets an error, everything is going to stop. For example, after let me see. After file, we want to print the first five rows in the file. We're using the df head. Now, if this first one, if this does not run, the second one will definitely not run. File error. It is going to give us a file not found error. Now, okay, we have a system whereby we want it to run in such a way that the file is not too important and the file should not stop our system from running entirely. How we're going to do that is how to handle errors whenever it happens, especially with when a file is not found or any other type of error in our system. Now, since this is giving a file found error, we're going to write a code that will handle the file not found error. And how we do that is using try and except code block. Now, how does it work? Sorry. Now, how does it work? First, we start with try. Try is a keyword. So after try, we put a semicolon, like a semicolon, then we state all what we want to happen. We state all what we want to happen here. Then after that, we do an except. Now, the exception we want is a error. So after the exception, except, we put the kind of error that we want to accept here, a semicolon, and then we put what we want to happen if this exception error happens. So now we're trying to read this file and it is not available. How we are going to handle this error is in the try part, we are going to read the file in the try part. That is read our CSV file. Now, if the file, let me put this as a comment. Now, if the file is not found, the error we are looking at here is this error, file not found error. So, except file not found, okay, except file not found error, semicolon. Then what do we want it to do? We want it to, like, say print, let's just print for now, print file missing file missing a new line, continuing with the process. and then we run. Okay, so from this we can see that error cannot and will not affect, the error will not affect, we can see that the error will not affect our pipeline as it is right now, because we have used the try and except methods to catch and to handle this error. So if this error comes up, it simply prints this, and if we have any other thing to continue, if we have any other thing, let's say, okay, we do not have, okay, let's just print something else. Print good to go. Okay, so our system can easily move and continue, the pipeline will seamlessly move. So we have caught this error, because we have caught this error. But if you're in a situation where you do not catch errors like this, what it does is it abruptly stops every process that is every process that is ongoing. It halts everything, and that's where you hear that your pipeline has broken. So we're just going to look at, we're going to use one data frame here, one data here. Let's do this, and just do some okay, some exercises on this. Okay, so we have this. I don't want this. Just from to run that spectrum. Now, this is already available as a data frame. Now, this data set is already available. This is on data camp. So this data set, using the data lab, most of these data sets is available there for everyone. So you can use it for your own practice if you want to. Now, this is the Yukon company's data frame, which is available on your data lab. So we're going to look at this and just basically look at, just do a basic exploration, and that would be the end of our class today. So looking at this now, okay, I want to, okay, we're going to go here. So now this comes in here, is already here as available as DF. So we can always call this DF. Let me hide this. So we're going to work with that data, use it as a data frame. So to view the first, of course, the first 5 records on our data frame, we use the head. Now, by default, if you do not put anything here, it gives you the first 5. But if you want to see the first 10, the first 2, the first 5. So if you want to see the first 2, first 10, the first 100, you just put the figure, the number there, and run. So this should give us, this gives us the first, the first 3. And to see the bottom 5, we use the tail method. Right. Okay. So we'll run this and we'll see the bottom 5. That's still the same thing. Oh, this came in with just 5. So we don't want to limit it. So, okay, so yeah, we now have everything here. Can now go. So if we run the tail once again, we're going to see something. Okay, so we have the bottom 5 records in the data frame. So head gives us the first 5. Fine. Then of course, one thing you also need to know the data types that are available, and to basically view an overview of what the data frame is all about. We use the info method, info. Okay, so info here now tells us that this gives us, first of all, we have the column names. That's company ID, company, country, city, and continent. Then this also gives us the number of non-null values. That's the values that are not null. We have that everything is complete. Then the data type, we have the data type int, object. Object is equivalent to string. So when you see object, you know it's a string data type. There's something here. Looking at using our head, we can see that the second record in city is empty. However, using the info method, we can see here that we do not have any null value. Everything is 1074, including city. Head here is showing us something different. Now, this means that though this place is empty, but it's not our environment is not seeing it as a null value. It's not seeing it as a null value. And these are the things that using the null value. These are some of the things that we can easily handle when importing using the read CSV, the read Excel functions. It has space to handle null values and how to handle when they enter before they actually enter our environment. However, we already have this. We have a head. We can see this is empty, but coming to our null values here, we assume that it is not empty. So how we can solve this is simply by using the replace method. And one function we can use is is from the NumPy library, the null function, the num function. That's one function we can use, and we use it to replace all empty values with null, so that when we read with the info method, it would see those values as null. Now, for us to do that, we have to import the NumPy library. I think we only imported pandas. Let me see. Yeah, we only imported pandas. So to use the null method, we have to import the NumPy library. NumPy NP. Okay. All right, so it has imported. Now we're just going to handle this because it's, first of all, you have to view your data, explore your data, then after that, you know the steps that you take care of, the steps that you handle in the transformation stage. Now, what we're just going to do is part of what should actually be in the transformation stage, but we'll just do it now. So here we want to, all empty columns, we want to replace it with null. We want to replace it with null. And what we use the replace keyword. First of all, we have to call our data frame. Our data frame, and which column? Column. So city dot replace. We use the replace function. Now, what are we replacing? We want to replace all nulls with NP null. So anywhere that is empty, replace it with null. And then we're going to use another option, in place. In place equals true. Now, if we want to replace, if we run this, we're going to replace for only city column. This is going to affect only city column. But we do not know if there are other columns that are affected by this same issue. We can't see all the columns in our data here to see if there are some others that are affected by this same issue. So what we can do is, rather than replacing that of only the city column, we can actually do for all of our data frame. We can do for all the columns in our data frame. And then it replaces any instance where we have an empty string, it replaces with a null string. So we run this, and okay. Then next we're going to use info again to view and see if we have any null value now. So df.info okay. All right. So now looking at city value, we can see that there is a difference now. That is only the city column is actually affected by that. The other columns in the data in the file, they are all actually complete. They all have values because they all remain the same, 1074, but only the city column reduced. So only the city column is affected by that problem that we noticed. So right now, if you call on np and if you check for null values, we're going to see the number of null values that each column has, and we can do that by using the is null from okay. So from this now we can see company ID has 0, company 0, city has 16 null values, country has 0, and continent has 0. So this are some of the ways we get to explore, first of all, our data, get to ingest some of this data, this file formats. We talked of Excel and CSV, the CSV, not that important. But this is how we get to ingest some of them in our environment and then explore them, and we just did just one translation here, which is checking for null values and all that. So this is basically how we do that in Python. So we're going to stop here today. And next week we'll continue. We'll look at working with APIs. Am I still on? I believe I am. Hello, can someone hear me? Oh, really? Can anyone hear me? Okay, thank you.
Yes, ma, we can.
Yes, I can hear you.
I'm talking to myself again all this while. Thank you very much. So we're going to stop here today. Let me stop sharing this. Okay, so we're going to stop here today. Then next week we're going to work with APIs. I'll have to look at how that works in Data Lab. Then we'll use Data Lab to work on APIs next week. So, attendance, I have forgotten. Sorry, let me send the attendance. Where is it? Okay. So I've sent the attendance. Please do what's right, and I completely forgot. So so that's what we have for today. So if anyone has any question, you could please go ahead and ask your question. Seems like I'm the only one here today. Can anyone still hear me? Okay. So
Yes,
since
we
no
can hear
one
you.
is saying anything, that means there is no question. And that's fine. All right. So next week we'll look at APIs. We'll look at working with APIs. And I'll send you the assignments as usual after this session. I'll send you the assignments as usual. And if there is anything, you can always visit me or send me a message on this code. So since no one has any question, I don't have any question prepared for today. So I guess we'll have to call it a day today. And please make sure you write your name in the attendance. I've sent it. So write your attendance and let's call it a day. So thank you for joining. I believe we'll see next week again. These people talk is their price. Right. Thanks.